Welcome to qnawire.
Draw a schematic diagram here of the projectile that is launched from A. Okay, and now we will calculate the horizontal distance from A to B. So we have x is equal to x naught plus v sub x naught times t, where here x naught is the initial horizontal displacement and v sub x naught is the initial velocity along the horizontal direction, and t is the time taken to reach the projectile at B. So then we substitute in 0 for x naught, v naught cosine alpha for v sub x naught, and r for x into our equation, and we get r is equal to v naught times cosine of alpha t, where here v naught is the initial velocity at an angle of alpha. Okay, so then we are going to calculate the vertical distance from A to B. So we get y is equal to y naught plus v sub y naught t minus 1/2 times g times t squared, where y naught is the initial vertical displacement and v sub y naught is the initial velocity along the vertical direction, and g is just the acceleration due to gravity. So then we go ahead and we substitute in 0 for y naught, v naught sine of alpha for v sub y naught, and h for y, and we end up with h is equal to v naught times sine of alpha t minus 1/2 times g times t squared. Okay, so here v naught is the initial velocity at an angle of alpha. So we get v naught sine of alpha t minus 1/2 times gt squared is equal to h. So we continue this and we simplify this, and we end up with gt squared minus 2 v naught times sine of alpha t plus 2h is equal to 0. And then we just solve this quadratic, right? We end up here with a quadratic equation. So then we can solve this quadratic for t. So we just use the quadratic equation here, which says that t is, well, equal to 2, well, we get negative 2 v naught sine of alpha, which becomes 2 v naught sine of alpha, and then plus or minus the square root of v naught squared times sine squared alpha minus 2gh, all divided by 2 times g. Okay, and we're going to then go ahead and simplify this, and then we can ignore the negative value of t. So we get that t is equal to v naught sine of alpha just plus the square root of v naught squared times sine squared alpha minus 2gh, all divided by g. Okay, then we are going to calculate the values of r and t by solving the equations. We get r is equal to, well, we get v naught times cosine of alpha t. So we just substitute in 30 miles per second for v naught, 9.8 meters per second squared for g, and 10 meters for h. So we get that r is equal to, well, 30 times cosine of alpha over 9.81 times this here. So we get this becomes 3.058 times cosine of alpha times 30 times sine of alpha plus the square root of 900 times sine squared alpha minus 196.2. Okay, and then we calculate the value of the launch angle for the maximum range by applying the condition where we have the derivative here, dr d alpha is equal to 0. So then we go ahead, we can use an online solver to solve this for alpha and get that alpha is equal to 48.5 degrees. So there's our first answer here, 48.5 degrees. And then to calculate the value for the maximum range, Well, we just substitute in our 48.5 for alpha, and we get that r is equal to 3.058 times cosine of 48.5 degrees times 30 times sine of 48.5 degrees plus the square root of 900 times sine of 48.5 degrees minus, if I squeeze it in here, this is minus 196.2. Okay, so we evaluate this and we get 81.13 meters. So therefore, the maximum range here is 81.13 meters.